For how many values are the tangent lines of these two functions parallel? So essentially what we're trying to do is we're trying to find out where the derivatives equal each other. Eventually you're going to do this. You're going to see um, where, what x values, when you subtract these, do you get 0? Okay, so let's find the derivative of f first. Now I relabeled it just so I don't have to say question or function y and function y. I have function f and function g, so they have two different names. Okay, so for f, the derivative would be uh, cosine x, negative sine y. I'm sorry, negative sine x. So just take the derivative of sine, take the derivative of cosine. And then for g, g kind of looks uh, like uh, like it's really hard because of those fractions. It's not that bad. Let's rewrite the g. Let's see. Instead, I'm going to say 1 over 12 x to the third, 1 half x squared, and 1/4 x. And so I just took the x's off the numerators. And now when I take the derivative of it, I'm going to multiply the 3 times the 1 over 12, which is 1/4, x to the second. And then we have x because 2 times 1 half would just be 1. And then we're left with 1/4 at the end. So we got to set these dudes equal to each other and see where they are equal to each other. So cosine x minus sine x equals 1 over 4 x squared minus x minus 1/4. So where are these guys equal to each other? Man, you know what? There's no indication on this problem that you should use a graphing calculator to help you out with this. um, but I'm pretty confident that that would be the best way to solve it. Now, I don't like fractions very much, so I'm going to multiply everything by 4. It's not going to change our results. So we have x squared minus 4x minus 1. The right side is not factorable, which leads me to believe even more so that we should use a graphing calculator to figure this out. So how would we use a graphing calculator to figure this guy out? Well, what we're going to have to do is we're going to have to graph them and then see where they intersect. Now, it's not over the whole graph. It's just in the domain that it specifies. Oh, but it doesn't specify a domain. Okay, so let's just see what we get when we actually do that. Oops, that's not what I want to do. Okay. All right. So let's get our functions in the window right there. Okay. So using your graphing calculator, go to the y equals button, and then we're going to put in, let's see, 4 cosine. And as soon as I press cosine, I'm always reminded that I need to check to make sure my mode is in radians. Okay, it looks like I am in radians, not degrees. We want to be in radians. And then I just have to hit y equals to get back to it. So we have cosine. Let's make this, there we go. We have cosine, and you guys can't even see the top right there. Let's get out of that one. I'll go down to here and put cosine in there. So we have 4 cosine x, and then we have minus, let's get out of that, minus 4 sine x. And then for our other function, we have x squared minus 4x, x squared minus 4x, and minus 1. Okay, I hit graph to see what it looks like. And I can see that the parabola only, let's see, it intersects the lines at 1, 2, 3, 4 points. So the way you're going to find those points is by using the intersect function. So you see at the top of the buttons, there's a button that says zoom. No, not zoom. It says trace. and there's a calc word right above trace. So hit second and then calc. And what you're going to select here is the intersect. So I'm going to select 5. And to find out where these functions intersect, I need to pick a boundary to the left of my first point of intersection and then press enter. And then I'm going to select the boundary to the right of my first point of intersection and press enter. And then my calculator automatically finds where they intersect right away. You can see the answers right there. We have, oh, actually, you know what? We don't actually have to know the number. But anyways, the first number where they intersect is negative 0.79106. And I just realized on on the question, it just says how many times or how many values are the two tangent lines parallel. And it looks like it's 1, 2, 3, 4. So our answer is going to be 4. It's extra to find all the points of intersection, but anyways, I explained how to find one of those points of intersection.